Hello, Zalalam from 2620 is active. Today we will have a discussion on inheritance. But before that, if you are new to my channel, please subscribe. And if you like the video, share, comment, and like. So, inheritance in Java is one of the foundational concepts that's integrated in the language as part of the object-oriented programming construct. So when we say inheritance, we mean that we include the definition of members of a class into another class using the inheritance construct. So if a class inherits from another class, the inheriting class accesses the members and other definitions in the class in various ways for its implementation. So when we use an inheriting class, the inheriting class will implement its specifics, and the inherited class indicates the general forms that has to be implemented in similar or specialized classes. So as we have said, it is a cornerstone of object-oriented programming construct, and the inherited class or the superclass implements or creates the general format or traits or attributes of classes that need to implement when they inherit. Okay, and the inherited class, or the class that describes the general format to be inherited by a specialized class, is sometimes called superclass or sometimes parent, and the inheriting class is called subclass or child. Okay, so to implement inheritance, we use specific constructs in Java. That means we use a specific syntax used in Java to inherit or access members of an inherited class, and we use the keyword extends, okay, after the definition of the class, and this word is followed by the class to be inherited. So to see an example, here we have got a class called shape. Okay, so this defines general formats of a shape. Here for simplicity, we passed it with a series of dots, and the inheriting class will be defined as like this. So the square class is a type of shape, and it extends shape, so it will implement its specifics, but also takes traits of shapes common to all shapes from the shape class. Okay, so that's how we implement inheritance in Java programming. So what is a construct or concept or mechanics of accessing members in inheritance? So if fields or members are defined as private in the superclass, they are not accessible to the subclass. Okay, the subclass needs to access those members indirectly, as it has been discussed before in previous lectures, that private members of a class are private to itself, and it will allow access to those private members indirectly through other methods, public methods. So that's how it accesses it. Okay, and the other important thing is a class can be inherited by many classes. That means we have got a shape class in the previous example, so we have got a square that inherits the shape, and we can implement a rectangle class that inherits shape, a circle class that inherits shape. Okay, but a class cannot inherit from many classes. Okay, so if we have got another class called figure, so we cannot inherit at a time in the rectangle class from shape as well as from figure. So a class can inherit only from one class. Okay, if we want to implement multiple interfaces, we will see in subsequent lectures how to implement that using Java interfaces. Okay, for now, class inheritance is mainly implemented by the inheriting class only from one class. Okay, and the other important concept is superclass reference. That means declaration of a class using the superclass can reference subclasses. Okay, it can reference subclasses. That is only reference, even though the reference variable is of superclass type, it cannot access fields of the subclass. Okay, so for example, the square class has its size, which is the four sides are equal, so there is one size. If there is no definition of size in the shape class, even though the shape reference can refer to the subclass square, it cannot access the fields of the subclass. Okay, so that is very important to address. So to access some of the properties of the superclass, we use the super keyword. Okay, we have discussed it in the methods section, particularly in the constructors discussion, but super has got other implementations too. So super is very important to implement the superclass constructor. Okay, so we will exercise on superclass constructor implementation in our lab exercises, and to implement the superclass constructor we use the superclass, and if there are arguments to the superclass, we include those arguments in the super keyword. If it is a default one or without arguments, then we will give empty parentheses. Okay, the other important implementation of super is it is important to access its private field implementations using super. Okay, using super, so it's very important that we use super when we have private field implementations. And the other important use of super is to access hidden member in a class. So when we say hidden member, if we have got a variable called size1 in the shape class, and we have got a variable in the square size1, that means the names of those variables are the same. So to access specifically the size1 field in the superclass, we use the super keyword followed by a period and then the name of the field. Okay, so that is very important use of superclass. And the other important concept in inheritance is order of constructors execution. Okay, even if we do not call the keyword super, so as we have discussed, super is important in implementing the constructor of the superclass. Even if we don't call the super keyword, the constructor execution follows the order of the definition of the class. That means first the superclass constructor is executed, then followed by the subclass. So if there are multiple hierarchies, that means if a subclass is also inherited by another class, so the steps of constructor execution follows those hierarchies. Okay, and the other important concept that we have to address in inheritance is method overriding. Okay, so this is one of the important implementation strategies for polymorphism, and particularly runtime polymorphism is implemented using method method overriding. So when we want to override a method in a subclass from the superclass, we have to have a method with the same name and signatures in the subclass, and it is recommended to use the annotation of overrides before the implementation of the overriding method. Okay, and as we have discussed, it implements runtime polymorphism. That means polymorphism is having one code with multiple interfaces. So this implementation is one of the strategies, as we have discussed in the method section. Overloading methods is one of the polymorphism implementation strategies, and the other strategy is the method overriding in class inheritance. So it implements runtime polymorphism, means the specific method, that means whether the method from the superclass or the method from the subclass is selected based on the reference that accesses the method at runtime. That's why it's called runtime polymorphism. Okay, and this concept is sometimes called dynamic method dispatch. Okay, so it occurs during runtime and the method is dispatched during runtime, and even if the reference variable is of the superclass, it applies for the runtime polymorphism. As we have discussed, we can use the superclass reference variable to refer to the subclass, so that also applies in the runtime polymorphism as well. The commonest way of creating general forms or general traits of a class definition is using abstract classes. Sometimes you use classes which are not abstract, but commonest implementation is using abstract classes. Abstract classes are defined using the keyword abstract before the keyword class in the class definition. Okay, so we call abstract class and then the name of the class. Okay, and this is used to define the general form, and it's not required to have specific implementation in the methods. You can have implementations of methods. In that case, you will use the implementation of the method in the abstract class, but if you want to have the general form or method in the abstract class, you'll define it as abstract, the method itself, and then if a method is defined as abstract, it must be overridden by the subclass. Okay, and when classes are defined as abstract, they cannot be instantiated. That means, as we have seen in our previous example, if we define the shape class as abstract class shape, then we cannot say shape1 is equals to new shape. Okay, because abstract classes are not instantiable, but they are used to specify the general format of a concept or a class, and then specialized class will implement their specific details. But the reference variable of abstract classes can be used to refer to the subclasses, and methods, as we have discussed, can be defined as abstract, or it can be defined as implemented method, as we have seen in our previous exercises and discussions. Implemented methods can also be used. When abstract methods are defined in the class, they must be overridden by a subclass. Okay, the compiler forces you to implement those abstract methods, otherwise it will flag error. The other important concept that we have discussed in the methods lecture is a final, and final is very, if you remember, we have discussed that final is very important. Final keyword is very important in inheritance, and when final is used with fields, okay, in Java, it means that field or variable is a constant value. That means it cannot be modified. And when a variable is defined as final, it has to be instantiated or defined within the same line. Okay, if you define an integer called number as final, then you have to provide a value on the same line. It has to be initialized on the same line. Okay, when it is used with a method, it means it cannot be overridden. Okay, if a method is labeled as final with any return type, then that method cannot be overridden, and a method cannot be both final and abstract. So if the method is final, it has to have implementation, complete implementation, so that it can be used by inheriting classes. Okay, and when it is used with classes, it means that the class cannot be inherited. Okay, so when we define a class final, if we define the class square as final, that means we cannot inherit from the class square. Okay, so that is one important concept. And all methods will be automatically final, and the keyword final cannot be applied to abstract classes. As you know, abstract classes are designed for implementing inheritance, and if you add final, that means the class cannot be inherited. So the compiler will complain if you use both final and abstract. So it is very important that we know when to use final. Okay, these are the main concepts in Java inheritance. We will do inheritance exercises in our lab exercises. For this video, this is what I have for you. Thank you for your time.